I bought 7 different brands of parallel clamps to test their performance and ultimately answer the question, do they even apply parallel pressure? And if so, which one is the best at it? For this video, we have the Jet, Bessey, Bora, Irwin, Jorgensen, Harbor Freight, and Taylor tools that are all 24 inches in length. First, I want to state up front, I bought all of these clamps with my own money and none of them were supplied by the brands for free, even though some of them wanted to, because I think it's important to eliminate bias when making a video like this. Okay, let's take a look at some notable features and ergonomics that sets them apart. The Jorgensen, Irwin, Taylor tools, and Bora all have a nice rubberized handle, which is probably going to help with better gripping and perhaps help me apply a little bit more clamping pressure. And of course, we're gonna test that, right? The handle threads vary between brands, but the Jet and the Bessey seems to be a little bit more beefier. The Taylor tool, Jorgensen, and Irwin's all have smooth bars and the rest have ridges on them. When clamping, you can expect these smooth bars to mar over time, but will the fresh bite into the metal give it an edge over the other brands? We're gonna have to find out. The bars on any clamp, doesn't matter if it's a parallel clamp or F-style clamp or anything else, they play a crucial role because it takes brunt of the clamping forces. So a thick and strong bar should not flex as much under pressure, whereas a thinner bar would bow and cause the jaws to sprawl outward, and that would make for uneven pressure from the top to the bottom of the jaw. To get a sense of how beefy these bars are, I'm going to measure their dimensions. This Jet, for example, measures 0.36 inches thick and 1.15 inches wide. After measuring the rest, you can see they're all pretty similar in dimensions, with the Irwin, Jorgensen, and Taylor tools brand being slightly beefier. The last critical factor on the strength of these bars is their geometry. They are fairly different from each other, and it is really difficult to measure how the geometry may impact overall strength of the bar. But of course, that is exactly why this channel exists, because I am an obsessive lunatic. So I'm going to open the clamps out to 24 inches and using a thick piece of wood with a load cell at the end, apply 250, 500, 750, and 1,000 pounds of pressure. I can then measure the amount of deflection on these bars by putting a precision straight edge on the spine and a feeler gauge to measure the amount of deflection. Keep in mind, it is impossible to hit the exact amount of pressure and have these clamps maintain it. So my measurements were taken within 5% of the target range, in most instances much better than that. This is also a good time to mention that I used 2 clamps for each brand in all of the tests, and every single experiment discussed here today is done in multiple iterations so that the numbers are averages. This way, a bad clamp or a bad test sample will have a much lower chance of messing up our data. Anyways, enough disclaimers. The bar deflection test gave us these results. There are 2 points that I would take away from this test. The Irwin was an absolute champ with the least amount of bar reflection at every level of pressure that we tested. On the opposite side, the Bora and the Harbor Freight did the worst. The next test is a little subjective, and in order to make it slightly more fair, I'm going to blindfold myself. I'm going to open these clamps out to 24 inches again and pretend like I'm gluing a panel and apply the normal amount of pressure I would apply by feel. And because I am blindfolded, I won't know which clamp I'm using or what the pressure output is. In this test, the ergonomics of the handle, feedback from the clamp to my hands, as well as any secret sauce within the clamping head will really shine. As I grab the first handle,
ooh, that feels familiar.
I'm going to clamp it by feel. Turns out, this Bessey produced an average of 651.33 pounds of force. Repeating the same method for the rest of the clamps gave us the following results. It is clear that the Irwin and the Harbor Freight Bremen are able to apply more pressure without really feeling like it. Okay, I'll admit, that test was not very scientific, and I need to know which clamp will apply the most clamping force for the least amount of effort from these hands. Per Dr. Google, an adult human wrist can comfortably apply 85 inch-pounds of force. Actually, it wasn't Dr. Google. I read way too many scientific papers on this topic, and now I'm just really curious and I need to find out what my own rotational torque is.
All right, let's see how this goes.
Not so average now, am I? For the actual test, I created this contraption to secure these clamp handles so that I can torque exactly 85 inch-pounds of force by measuring with a digital torque wrench. These are the results. For the same amount of forces applied, the Irwin, Bora, and Bremen produce the most clamping pressure. So if you're an older adult or have medical conditions that may impact your gripping strength, you might want to consider these clamps as they take the least amount of force to generate the most amount of clamping pressure. Now, to be fair, you don't actually need to crank a clamp like the wood owes you money. In most woodworking scenarios, a few 100 pounds of pressure on a properly milled stock is more than adequate. And all 7 of these brands will get you there. But these clamps do come with a pressure rating, right? And is that really achievable with now slightly above average hands? Or are they just marketing hype? The Irwin claims a maximum clamping pressure of 1,150 pounds. Now, you've seen enough testing on this clamp to know that this is very much achievable. And with my single dominant hand, I was able to get an average pressure of 1,413 pounds, and with both hands cranking as hard as I can, I was able to achieve 1,678 pounds of pressure. And that's not a mistake. I tested both clamps and did multiple tests. The Irwin truly punches above its rating every single time. The Bessie claims a maximum clamping pressure of 1,700 pounds, and with a single dominant hand, I was able to achieve an average of 704 pounds. And going absolutely ham with it with both hands, I was able to achieve 1,011 pounds and squealed like a little pig in doing so. I don't know about you guys, but 1,011 pounds is far less than the claimed 1,700 pounds. And I love my Bessie clamps, but who the heck are testing these clamp ratings? Anyways, here are the results for all of the brands broken down by single dominant hand operation and two-handed operation. And while it may take both hands, the Bora and the Bremen were also able to meet advertised clamping pressure along with the Irwins. Everything else came close but failed, and the Bessie failed spectacularly. So far, all of these tests that we've just done can be applied to most clamps like bar clamps, pipe clamps, and F-style clamps. But that's not the reason why you buy parallel clamps, right? You buy them to make your woodworking friends jealous, and if that's not the American dream, I don't want anything to do with it. But secondary to that, we use parallel clamps because they apply parallel pressure. It's in the freaking name, right? So we want to see parallel pressure being applied through the entire length of the jaw. And as a result, these clamps can help reduce the glue-ups from looking like a smile or a frown. We want dead flat expressions. By the way, before going into this test, I want to clear something up about parallel clamps. They have a fixed jaw and a moving jaw. The moving jaw has a little bit of wiggle room to it that should adjust itself as you apply pressure to ensure that the two clamping heads come into parallel. This is done by design, and putting a square up against the jaw is not going to give you a ton of meaningful information. In fact, you want a little bit of gap at the bottom of the jaw in the closed position, and we'll talk about that in a little bit. Okay. Onto the parallel test, and for this we will need 2 load cells, and if you thought the parallel clamps were expensive, these take it to another level. So subscribe if you want to support my bad spending habits. I don't know. Anyways, these load cells are exactly 3 inches in length, and using 21 inches of a sturdy piece of wood that is precisely square, I'm going to place one sensor at the bottom of the jaw and one at the top of the jaw. And if these clamps apply parallel pressure, both of these readers should show the exact same value. I'm going to do this test in the low, medium, and high pressure setting that will be set to 250, 500, and 750 pounds of pressure. I tend to think of 500 pounds as a good middle ground for an average clamping scenario, and that is where we really want to see these clamps come into perfectly parallel pressure. To start the low pressure test, I'm going to apply pressure until one of the sensor reads 250 pounds, write down both of the readings, and repeat this test 5 times on each of the 2 clamps per brand. Then I can average the measurements and compare the percent difference between the top sensor and the bottom sensor. At 250 pounds, the jet, for example, had 25% more pressure at the top of the jaw when compared to the bottom of the jaw. Seeing the results across all of the brands, surprisingly, the Taylor tool comes in at the closest parallel pressure at the 250 pounds test. At 500 pounds, this is the result we get, where almost all of the clamps get worse at applying parallel pressure, and at 750 pounds, this trend largely continues with the Bora making a surprising comeback. Not a single clamp at any of these readings actually applied parallel pressure, not even close. And in some instances, they were applying nearly 70% more pressure from the top to the bottom. That is shocking to me. Why are these even called parallel clamps? Turns out, parallel clamps are surprisingly complicated tools, and the applied load are dependent on a lot of factors, like the rigidity of the bar, which is the reason why we tested it earlier, the amount of initial towing of the jaws, the amount of pressure being applied, the material and structural composition of the clamp heads, and so on and so on. So all of these factors are working together at the same time, and they're constantly changing as you apply more and more pressure. So trying to measure the parallelness of a clamp at a predetermined load like 250, 500, and 750 pounds is probably not the best way to go about it. And here's what I mean. So at the beginning, when we apply some pressure, you'll notice that this one at the top here is in the leftmost. You can see it applies more pressure than on the bottom one. And that's because the jaws are probably prawled in this fashion such that at the top, they're applying more pressure than at the bottom. But as you continue to apply more and more pressure, the idea is somewhere between the bar flexing as well as some of the mechanics within the jaw, they kind of go from here to being in parallel so that it can apply parallel pressure to your workpiece, which is the idea, right? But where is that point exactly? And in this case, as we continue to apply more and more pressure, we'll see these numbers come closer and closer and closer to each other. And it's probably, let's see here, and you can see it's in that 200-pound range or so. And so they were pretty different from each other. Now they're very close to each other. And as we continue to apply more and more pressure, they start to diverge away. So now in this case, the jaws are opening up more due to the pressure. So there's less pressure here and more pressure at the bottom. And this seems to be how pretty much every parallel clamp works. Actually, I spoke way too soon because not all clamps have a point where they eventually get parallel. Here is an example. On the other hand, we have this Bora parallel clamp where the first thing you'll notice is that the difference between the two readings from the top and the bottom of the jaw is pretty big. So the jaws are pretty skewed to start off with, and that's the case for both of the parallel clamps that I have. And no matter how much you crank this, these two numbers never really meet each other. So that means the jaws never quite adjust enough to get us to being actually parallel at any pressures that I can reasonably apply here. And so really, this parallel clamp doesn't apply parallel pressure. In my testing, I found that the jet applied parallel pressure at around 131 pounds, which is way too low in my opinion. The Bessie came in at around 199.66 pounds, which is a little bit more, but still not quite enough pressure in my opinion. The Jorgensen was pretty much all over the place, but averaged in at 142 pounds. The Bremen/Harbor Freight one came in at 149 pounds, and the Taylor tools came in at 239 pounds. Unfortunately, the Bora and the Irwin were really all over the place and could not generally produce parallel pressure. I have to be honest with you guys, spending all of this money to make this video, I was really hoping to find a clear winner when I conceived the idea for this video, but when you consider all of the tests, there are no clear winners though. I did find the Bessie to have the widest sweet spot in applying parallel pressure, as in it maintained a better parallel pressure across a wider range of pressures compared to the other brands. If you already own parallel clamps, don't change a thing unless it's Bora. If you're looking to buy new clamps to start a collection, buy whatever that fits your budget, but knowing what I know now, the Bessie would probably be my top pick, even though I personally enjoy using the jets much more. And if you're wondering, yes, my hands hurt like hell from the making of this video. Thanks so much for watching. I will see you on the next one.